Welcome to the Consequences of Modern Agriculture lecture for plants, humans, and the environment. This slide is taken from the previous lecture. We discussed how modern agriculture involves certain industrial technologies. After more than 10,000 years of farming being practiced in much the same way, the face of agriculture saw a major change only within the past 200 years. With fossil fuels and industrialization, farms were transformed into factories and farmers into employees. As seen in the last lecture, listed here are some of the key technologies that made this shift possible and are the foundation of our modern industrial agricultural model. We'll look at some of the consequences of this model in this lecture. Here we have listed some of the major consequences of the modern agricultural model. This list gives us an idea of how extensive the impact of agriculture is today. There are environmental, health, cultural, economic, and even political effects associated with the modern agricultural model. Let's take a closer look at some examples. First, the nature of farms has changed drastically. The demographic of farms has shifted. There are now fewer farms, but the farms are bigger. Farming has become consolidated. The U.S. Department of Agriculture reports that the number of acres per worker rose from 27.5 in 1890 to 740 in 1990. So we've got fewer workers per acre. According to the American Farm Bureau Federation, farm and ranch families comprise just 2% of the U.S. population today. And farmers and ranchers receive only 16 cents out of every dollar spent on food by consumers. In 1980, farmers and ranchers received 31 cents. The increased cost of inputs and things like packaging, shipping, and marketing have impacted the economic security of farmers. These demographic shifts translate into real losses in farming culture and farming skills. Farming communities are, in a sense, dying off. In fact, about 60% of the farmers in this country are 55 years old or older, and the percentage of principal farm operators 65 years or older has increased almost 10% since 1969. So farmers themselves are aging. During the 1980s, farmers began to really feel the economic stress of taking out loans to pay for the increased farm inputs. And actually, the number one cause of death for farmers at that time was suicide. Since that crisis, the suicide rate for male farmers is still high at almost 2% greater than the general population. In addition to cultural and economic impacts, there are significant environmental consequences. One environmental impact of agriculture is resource depletion. This also has economic implications as well, but can cause irreversible environmental damage. Erosion, for example, can remove from fields the soil needed to grow crops. Arable land, which is soil that can grow crops, is a limited resource. As you can imagine, intensive agriculture greatly impacts soil quality. Machinery, chemicals, and leaving a field unplanted will destroy soil structure, leading to erosion and loss of topsoil and nutrients from the soil. Depleted and degraded soil is highly susceptible to desertification, in which the land becomes like a desert. The soil can no longer hold together or hold moisture and therefore can't support plant life. Erosion happens when wind or water simply carries soil away. In 2010, the United Nations reported that desertification affects 25% of Earth's land area and jeopardizes the livelihoods of over 1 billion people in 100 countries. It can take up to 500 years for an inch of topsoil to be naturally generated. The National Academy of Sciences has determined that cropland in the U.S. is being eroded at least 10 times faster than the time it takes for lost soil to be replaced. For example, Iowa has lost about 50% of its topsoil since colonization, and 50% of that amount lost has been within the last 50 years. Americans experienced the devastating effects of poor soil management during the Dust Bowl era. Where does the soil go? When it's not airborne, it will end up in waterways, negatively impacting aquatic life as well as other industries such as fishing. The effect of this sedimentation can be seen downstream here in this image in the Gulf of Mexico. That's due to Mississippi River drainage. Pesticides and fertilizers are carried along with the soil when erosion occurs. Reds and oranges in this map represent high concentrations of phytoplankton and river sediment. The fertilizer runoff provides abundant nutrients for algae like phytoplankton to form what are called algae blooms. When the algae die, they sink and decompose in the water. That decomposition uses up the oxygen in the water and kills the aquatic life because there's no oxygen available for fish and other aquatic life to use. These areas are referred to as dead zones because there's such little life found in them. There are several hundred dead zones around the world. Marine life as well as the fishing resources are impacted by this. As more land is converted to agriculture worldwide, habitat for plants and animals is lost. Land resources are disappearing at an alarming rate. Agriculture is a principal cause of habitat destruction, and habitat loss is often the greatest threat to a species' survival. Around 50% of the world's habitable land has already been converted to farming land. Overall, farmland covers 38% of the world's land area. It is predicted that in developing countries, a further 295 million acres of natural habitats will be converted to farmland to be able to meet the demand for food by 2050. Also, water resources are being overused around the world, primarily for agriculture. We can see areas of high overuse in this global map. Combined stresses of climate change and withdrawal for agriculture is causing some reservoirs to decline drastically. Climate change has drastically decreased snow melt into the rivers that supply water for agriculture as well as drinking or other industries. At the same time, dams and irrigation have increased withdrawal of water. If withdrawal of water is greater than the replenish rate, then we'll see a decline in the water resource. That's what is happening to Lake Mead, which was created by the Hoover Dam. You can see the ring around the lake where the water level used to be. It turns white because the calcium in the rock reacts with oxygen in the air to form a coating of limestone. It's about 130 feet lower than it was in the year 2000. As of 2014, the river hadn't even reached the sea in 20 years, but a man-made flood of about 34 million gallons of water was recently released in the river channel in an attempt to restore habitat downstream. This is happening worldwide. The Aral Sea is on the Kazakhstan and Uzbekistan border and was the world's fourth largest lake. Its two largest rivers feeding into it were diverted for agriculture in the 1960s. As the lake disappeared and the ground lost water from evaporation, the salt concentration increased. Erosion also brought fertilizer and pesticide contaminants into the area. The region became essentially a toxic desert with more frequent dust storms, further blowing salt and contaminants around the region. You can see in this image boats stranded where there used to be water. Those are examples of surface water depletion, but most of our available fresh water lies underground in aquifers. Those are also being depleted rapidly. For example, the Ogallala Aquifer is one of the world's largest aquifers and is an underground water source under the Great Plains of the U.S. The Ogallala provides at least 20% of the water used to grow wheat, corn, cotton, and cattle in the whole U.S. An aquifer can take thousands of years to replenish, but withdrawal of the aquifer for agriculture is causing the water table to drop up to 2 feet per year. And we can see in this image that much of it is now less than 100 feet in saturation or less than 400 feet in thickness. This US map shows cumulative groundwater depletion for the years 1900 through 2008, with agricultural regions showing greater depletion. Modern agriculture also relies heavily on fossil fuels for direct inputs, such as fuel for machinery or transport, or for indirect inputs, such as fertilizers and pesticides, which are petroleum-based products. Although agriculture accounts for only about 2% of energy consumption in the US, energy inputs can represent a large portion of farm expenses. Most of the energy used on farms is for fuel, with fertilizers second on the chart. Because farming does require so much energy in the form of inputs, we might want to consider whether it's a good investment in terms of energy output in the form of food. And it may be that the energy flow is inefficient, since we get much less energy out than we put in. One of the things consumers have come to realize is that the food miles they are consuming can have an impact on energy consumption and ultimately climate change. For this and other reasons, there has been a movement to buy local foods. Food miles is the distance your food traveled to get to you. So you can see that if you cut out transportation and buy local, that's about 14% of the energy inputs. And if you buy from a local farm, that would also reduce energy inputs for the processing, packaging, and retailing of food. Okay, I'm going to stop this lecture now and ask you to open part 2 of this lecture for the remaining part.